And thank you all for joining us today. Let's see. Today we're going to talk a little bit about the NTA 3000 and its Wi-Fi capabilities. I wanted to make sure that I set the stage for what we've done with the RvR expansion. In addition to that, I'll also talk really quickly about some of CDRouter's performance capabilities, and then we'll get into what's new with RvR, what we've added, and also the rack kit that we have now. And then at the end, I'll do just a really quick demo, and then we'll open it up to Q&A. And as Jason mentioned, if anyone has any questions along the way that are relevant to what I'm talking about, Jason, please just pause me and we'll address those on the spot. So first, I wanted to get into just a real quick overview of the NTA 3000. This is a purpose-built appliance for CDRouter. The NTA 3000 is a significant bump in overall performance compared to the NTA 1000 that many of you may have experienced or used or may even have in your labs now. What we've done here with the NTA 3000, it's a 3U platform. It's significantly faster from a performance perspective, but it's also got all of the ports on the front panel, which is, in my opinion, the best feature of this new platform. It makes it much easier to work with if it's installed in a rack or in an RF chamber, for example. There's also a number of additional expansion slots on the front, as you can see, so everything is easy to get to, and there's a lot of slots for future expansion. The NTA 3000 has a number of different wireless capabilities. The most important one really is support for Wi-Fi 6E and Wi-Fi 7. There's 7 total radios in the system that can support up to 115 clients. And this table just displays the basic capabilities of the system. All of this is on our website as well. In terms of Wi-Fi testing with CDRouter, there's really 5 different components. So there's client connectivity, which is really the association, authentication, and key exchange. That's a big portion of what you can do with CDRouter in terms of Wi-Fi testing. Beyond that, sort of the second phase is client scaling. And really what we're talking about there is testing with multiple clients. Those clients can be either persistent or transient. And the difference there is that persistent clients are ones that are created during the start sequence within CDRouter, and they exist for the duration of the test run. So it's a way to sort of load down the device under test. Whereas transient clients are created dynamically within individual test case scenarios. CDRouter supports both modes, so you have a lot of options there. Beyond client scaling, the other big piece is what we call functional testing. It's really just verifying the core protocols and core functionality within the device under test. You can do all of that with CDRouter using all of the different wireless interfaces that are available on the system. We also, many years ago, added performance testing to CDRouter, so that's also an option as well. And then when you mix performance and functional testing together, you end up with the ability to do long-term stability testing, which is one of my favorite things. And it's a very useful testing exercise that always reveals really interesting issues. One other thing that's come up, there are a few questions that were on the registration form for this webinar about CDRouter's MLO capabilities. And I thought it would be good to just have a quick slide here about what the current status is. So I'm going to preface this by saying this is all as of April 2025. There's a lot going on in the Linux kernel in the MLO space. And as that evolves, we will evolve with it. With that out of the way, we did add support for multi-link operation in CDRouter 15.3, which was the last official release of CDRouter. It does require an upgrade to the operating system image on the NTA 3000. We call that the golden image. So you do need to upgrade to golden image 9.4 in order to take advantage of the MLO capabilities that are built into CDRouter. We currently support what's known as Enhanced Multi-Link Single Radio Only, which is EMLSR. There are many different MLO modes, and this is the only one that is currently supported by CDRouter. We did not add any new MLO-specific test cases or configuration options to CDRouter. So what you can do is test all of the normal functional performance and stability type testing over those new MLO-enabled SSIDs that many modern devices have now. The other caveat really here is that this is a Wi-Fi 7 feature, so you have to use CDRouter's Wi-Fi 7 card to test MLO. When you are connected to an MLO SSID, you'll also notice now in CDRouter's logs that there are additional debug messages that are printed. I just highlighted one here on the screen so that you can see what that looks like. All right, moving on. With CDRouter, I wanted to just talk really quick as well about the performance testing capabilities that exist. The CDRouter performance expansion is based on iPerf3. So we have a fully automated and integrated version of iPerf3 within CDRouter. It's very easy to use. It's highly configurable. There's a lot of different options there, a lot of different traffic profiles that you have access to. And a traffic profile is really the type of traffic that you want to send. And in addition to testing the overall performance of your device, the CDRouter performance expansion also enables you to do that long-term stability testing that I mentioned earlier. And long-term stability testing really is combining functional and performance tests together and then looping them. One of the things that I like to do is on a Friday afternoon before I leave for the weekend, I will take a new device that we may have added to our lab and start up one of these stability tests and let it run for 48 hours. And then when I come in on Monday, I can take a look and see what happened. And this is this screenshot that I have here in the slide is just one example of a device and how it behaved when I ran a stability test on it. And this is the kind of thing that we often find when we do stability testing. You'll see that performance is good initially, and performance typically will be good in many of these devices. If you run just performance tests, performance will be stable and good for a long period of time. But as soon as you start to mix in those functional tests, that's when things start to kind of go off the rails a little bit. And you'll see often that it doesn't take very long, in this case, less than 4 hours for this device to actually exhibit some poor performance and actually degrade significantly. We've talked a lot about stability testing. We have a lot of resources on our website for it. So I encourage you to check that out. If this is not something that you're currently doing, it's definitely worth taking a look at. There is a link here in this slide as well. And Jason will send out the slide deck after. So you'll have access to all of this information after the webinar too. In terms of performance testing features, as I mentioned, there's many different traffic profiles available. So a traffic profile is the type of traffic that you're going to send during that performance test, the direction, and whether or not it's IPv4 or IPv6, and so on. There's also a number of different configuration options available for CDRouter's performance tests. Probably the most important ones are the number of streams and clients, how long you want the individual test to run for, the target bandwidth. And then one really nice thing about CDRouter's performance tests is that the pass and fail thresholds are user configurable. You define those right in the config file. So if you're testing an SLA, or if you expect a certain DUT to have a certain level of performance, you can define what that is in your config file. And then when you run the performance test, it actually will generate a clear pass or fail based on what you've decided is the threshold. There's a few different types of tests available within the CDRouter performance expansion. There's a fixed rate and a configured rate type of test. And just to give everybody a quick overview of what that means, a configured rate test is one where the user will actually configure all aspects of the test case itself. So the number of streams and clients, the target bandwidth, the pass-fail thresholds, everything. It's configuration heavy, but it's also extremely flexible. To make things a little bit easier on the configuration side, we added fixed rate tests. And a fixed rate test sort of sets all of those parameters ahead of time. The user does not have to define those. We have a number of fixed rate tests for various rates and traffic profiles, and users can just grab those tests and run them. They don't have to configure anything else. So fixed rate tests are low overhead on the config side, but less flexible. So the benefit of CDRouter, of course, is that you have access to both. Choose which one works best for you. We also have, as with all testing in CDRouter, very detailed logs, lots of information there, which makes debugging very easy. And it's easy to share that information with your colleagues and partners if you do have issues that you need to work through. With CDRouter performance, another feature that we've added is graphing, and the graphing carries through to the RvR expansion, which I'll show some screenshots on that later. So CDRouter performance is a great expansion, and it is what enabled us to easily add all of the RvR tests that we'll be talking about in just a minute. All right, so with that background, we've had a few customers over the years tell us that it would be great if we could do even more on the Wi-Fi side with our performance expansion. And really what they were hinting at is that it would be great if we could expand that existing capability and add in an RF attenuator so that we could do more range versus rate type of testing. And so that's what we did. We added the RvR expansion just this past release of CDRouter, so just a few weeks ago. It's brand new. And what it does is add in those wireless range versus rate type tests to CDRouter. And that's all implemented using a programmable RF attenuator. And we have a kit that we offer with it, a hardware kit that goes with the NTA 3000 as well. So why does RvR testing matter? This is something that has come up. As I mentioned, we've had many customers ask us for this, but really the point of RvR testing is that it provides, it's a more realistic type of test. It provides just a better measure of real world performance. It also makes it easier to compare devices. So different Wi-Fi devices have unique rate adaptation strategies, antenna designs, chipset behaviors. RvR testing helps compare devices to just select ones that are better for specific environments. Poor rate adaptation strategies can lead to sluggish handoffs as well. And RvR testing is very useful in identifying weak areas there. And it also just ensures that the overall customer experience of your devices is good. Not everybody is in the home is going to be within close access to the access point. As we all know, homes are very complicated environments. Wireless is a complicated protocol, and everybody's experience can differ. So adding in that attenuation and being able to test at different attenuation levels is really eye-opening. So as we were thinking about how to actually add in RvR tests to CDRouter, what we decided to do actually is implement the RvR tests that already exist and have been defined by the Broadband Forum in TR398. TR398 is the Wi-Fi residential and SOHO performance testing specification. It's widely recognized, and many people use this as a benchmark for their Wi-Fi testing. It's very comprehensive. There's a lot of stuff in it, but what we did was pluck out just the RvR test cases. There were many of them that are well-defined and easy to understand, and that's what we implemented. Those tests are defined in section 631, and here's what that table is in TR398. We basically automated and implemented all of these test cases within CDRouter. So as you can see here, there's each column represents a different Wi-Fi mode, and then each row represents a different attenuation, target attenuation, and then the actual pass-fail criteria are listed for downstream and upstream in these within the table itself. In terms of requirements for adding the new RvR expansion to your CDRouter system, there's both software and hardware requirements. On the software side, you do need to have an active maintenance and support agreement with QA Cafe. As I mentioned, the RvR expansion was added in the last official release of CDRouter, which was version 15.3. So you need to have CDRouter 15.3 or newer installed. And then you obviously need to have the RvR expansion license added as well. The performance expansion is a requirement, and then optionally, if you want to do testing over RvR testing over IPv6, you do need to have the IPv6 expansion as well. On the hardware side, you need an NTA 3000, and then you also need the new Wi-Fi RF attenuator kit or rack. And I'll talk a little bit more about that in just a minute. It is also useful in many environments, not all, but in many environments to have an RF chamber. So we recommend that, and we can make recommendations on RF chambers if anyone needs help picking one out. The Wi-Fi RF attenuator kit or rack that we offer, here it is. This is all the pieces that are included with it. The big one here is really the RF attenuator, and that's this device that you see right here. This is an 8-port programmable RF attenuator. It's fully integrated within the CDRouter test environment. It's controlled by CDRouter. It's powered and controlled by CDRouter using USB. So all you have to do is plug this USB cable into your NTA 3000, and then I'll show you what the configuration side of it looks like in a minute, but that's all that you really need to do in order to be able to communicate with the attenuator and have CDRouter control it. The other big piece of the RF attenuator kit is the cabling, and this is actually much more complicated than it seems. What we've done here is everything that we ship to you has RP-SMA female connectors on it. So we will supply you with RP-SMA male to RP-SMA male cables to make that connection process easier. And if you are using an RF chamber with the rack, we can supply you with an extra set of cables as well. And if needed, we also have some gender adapters as well to convert between the different types if needed. So the last thing I'll mention here is that the cabling that we've chosen is LMR 240 equivalent cable. So when you purchase the rack, you'll get a box with all these goodies in it. Here's what the test setup looks like. This is what I call the small chamber test setup. This is one where the NTA 3000 and the rack are physically located outside of the chamber. They're not in the chamber. So as you can see, CDRouter is wired. CDRouter's RF ports on the front panel of the NTA 3000 are wired into the inside on the attenuator, and then the outside is wired into the back of the chamber. And then, of course, on the inside of the chamber, you'd have all of the tri-band antennas connected there. Here's the alternate test setup. This is one for testing in a large chamber, which is a chamber where you might have CDRouter and, the NTA 3000 and the rack physically inside of it. In that environment, you don't have to cable the outside of the attenuator. You can just connect the antennas directly to it. You can also use this setup for testing in open air as well. And I know a picture is worth 1,000 words. So here's what these different test setups might look like in a real lab. picture number 1 is that small chamber test setup. So this is one, again, where the NTA 3000 and the rack are located outside. They're not inside the chamber, they're outside the chamber. And then 2 and 3 here, images 2 and 3, are different ways that you can connect the NTA 3000 and rack in a large chamber or an open air type of environment. They're basically the same with one exception, and that is that in picture 3 here, we actually are using the magnetic bases that are an option with the NTA 3000, whereas in picture 2, the antennas are connected directly to the attenuator. Either one is fine. The magnetic bases are very useful because it does allow you to sort of physically move things around a little bit and give you a little more space if needed. Those magnetic bases are included with the advanced accessory pack for the NTA 3000, and the pigtails that are on those magnetic bases are 5 feet in length. Jason, before I continue, any questions?
There's a lot. I think we should wait till we get to the end before we do.
Okay, that's fine. That's fine. Let's see. All right, in terms of prerequisites for RvR testing with CDRouter, I can't emphasize this enough, and it's been challenging for us internally on occasion as well, but the test setup and the cabling is the most important thing. And it's easy to not get the cabling right. So you really have to pay very close attention to the cabling and make sure that you're using the right connectors and the right cables to match the gender of all the connectors in your environment. We've done our best with the rack to make sure that piece is as easy as possible. But if you're cabling the rack into another chamber that you may already have, it's very important that you make sure that you know exactly what gender is on your chamber so that you can purchase the right cable, or we can potentially supply you with an extra set of cables. But we need to know exactly what you need in order to make that go smoothly. So cabling, super important, and it's not as easy as it might seem. It also is important to make sure that before you even think about trying to test RvR, that you have working wireless configs for CDRouter and that you have some experience testing Wi-Fi with CDRouter. Obviously, you need to go through the process of building wireless configs before you can even begin to do this RvR type testing. We have a lot of resources on our website to help with the wireless config side of things. So
yeah. I was going to bring that up. So there are several other webinars and Brad's training series that will show you how to do the actual behind the scenes setup for performance in general and for Wi-Fi stuff specifically.
Yeah. Thanks, Jason. I have a slide at the end of this presentation with a lot of useful links in it as well, but definitely go to our website if you need help building those wireless configs or performance configs. And of course, reach out to our support team at any point in time. We're always happy to talk and happy to help. The other thing I'll mention that's unique to RvR is that TR-398 does actually have special configuration requirements on the DUT end of this. So if you really want to follow TR-398 as closely as possible, it's important that you configure the DUT according to what is listed in TR-398. You don't have to do that, but if you want to be as consistent as possible, you should be aware of what TR-398 says the correct configuration of the DUT is. All right, so once you've got those prerequisites understood and taken care of, on the CDRouter side, in terms of configuration, it's actually very, very easy to set this all up. There's only 2 test vars that you need to enable in your CDRouter config file. The first one is a new one. It's called supports attenuator. Just uncomment that, set that to yes. And that is what enables the automatic control and configuration of the RF attenuator from within CDRouter. And then the other thing you need to do is make sure that the performance expansion is enabled and active as well. And to do that, you only have to set the supports performance test for RTS. And that's it. That's the beauty of RvR testing with CDRouter. Everything else is done automatically by CDRouter when you select and run those new RvR test cases. So it's pretty simple. So in terms of the actual RvR testing, I'll show you a quick demo in a little bit here, but everything is made pretty easy with CDRouter. Excuse me. Everything is fully automated based on Section 631 of TR 398, which is that table that I showed you earlier. You don't have to set anything. We do it all dynamically within CDRouter based on the test case that you've chosen. We did add a few things to the TR 398 RvR tests. The current version of 398 does not have anything about Wi-Fi 7, so we did actually add some Wi-Fi 7 test cases in. And we've chosen pass-fail criteria that we think are appropriate for now. We know that the Broadband Forum is working on this. And in the future, when they actually define those pass-fail metrics for Wi-Fi 7, we will, of course, update CDRouter's test cases to use whichever value or to use the values that they've defined. We also added in IPv6 tests for RvR. That is again something else that the Broadband Forum did not do initially. So we've gone ahead and done that also. And one other thing that's really nice with CDRouter when you're doing this RvR testing is we have very nice graphs, which make it really easy to see exactly what's going on and understand what's happening. And I'll show you an example of those graphs in just a minute. All right, in terms of test coverage, the new RvR expansion includes 400 test cases. Here's a table that gives you the breakdown. And as you can see, they cover all three Wi-Fi bands and Wi-Fi 4 through Wi-Fi 7 as well, and IPv4 and IPv6. So a lot of new test cases here, and a lot of really good testing that can be done with the RvR expansion. In terms of test output, this is what you will see in CDRouter when you run the new RvR tests. This is a sample test log that I pulled from one of our systems. Anyone that's familiar with CDRouter has seen hundreds of test logs. So this is the same sort of test log that you know and love from CDRouter. It's available for the RvR tests as well. There's a very simple, very clear high-level pass or fail. And we also sprinkle in now additional wireless information when you run these tests. These little info blocks exist now within the current performance test cases when you run with a wireless interface. So this isn't necessarily new, but it is very useful for RvR testing. Maybe even more useful for RvR testing, because as the test cases run and as you select different tests, you can see how the signal and noise values change. You can see how the MCS levels adapt as well. So really interesting, really useful information here. All of the data that we provide is also available in a few different formats. So if you have a larger CI/CD system or an automation platform that you have integrated CDRouter into, you can pull data out of CDRouter in a number of different formats and make custom reports or basically do almost anything, which is really nice and very powerful. As I mentioned earlier, we do have these great RvR performance graphs as well. So this is a new feature. Graphing is not a new feature, but these RvR performance graphs are a new feature. They're a great way to really quickly see what's going on with the RvR testing as it's running. So I'll show you this in the demo portion in a few minutes. All right, there are some caveats as well with RvR testing within CDRouter. You need an NTA 3000 and you need to use our rack. You can't bring your own attenuator. Right now, we do not support that. So you do have to use the attenuator that's included in the rack kit. It does take a long time to run all of the tests. There's 400 test cases. If you want to run them all, they're about 2.5 minutes per test. So it takes about 18 hours. So it's not a quick test, but it is something you can run and get done in a day, which is great. The tests are not configurable. So they are implemented exactly according to TR398 with, as you saw earlier, no configuration options. So there's nothing there that can be changed. The tests run as defined. It does take multiple configs and packages to run all tests if you follow the guidance in TR398 on how to configure the DUT. So that's another caveat there. And the last thing I'll mention is CDRouter does not include a full TR398 implementation. All we've done is taken just section 631, the range versus rate tests, and implemented those. And it's also unlikely that we'll ever actually provide a full TR398 implementation. There are other tools out there that do that. And for our customers and for our testing and what we want to offer, really, we are interested in just the RvR test cases. So yeah, with the new RvR expansion, it's really easy to add to existing CDRouter setups, which is a nice benefit. If you already have an NTA 3000 and you're interested in doing RvR testing or even just more wireless testing, you have everything you need now to get started. Add that rack and add the new RvR expansion, and you're ready to go. As with everything in CDRouter, the results are easy to understand, easy to use. You can share those with your customers, with your partners, and reproduce issues very quickly. And of course, you have a great team here at QA Cafe that will support you if you have any questions or if you need anything. And we are also always interested in hearing what customers are doing with our tools and evolving them over time as well. So with that, let me just jump, Jason, I'm going to jump over and hop onto a CDRouter system really quick here, and then we can do some Q&A at the end. So let me go here. All right, Jay, is that, can you see everything there?
Yeah, looks good.
All right, so here's a CDRouter system in our lab. What I've done basically is just run, I didn't want to run this in real time. The tests do take 2.5 minutes, so it's not that interesting to watch because it does take a little time to see anything interesting. So this is a canned result, one that I ran a couple weeks ago, just to give everybody an overview of what's going on here. So what I did here is I ran all of the AX, so the Wi-Fi 6 RvR test cases against a device in our lab. And here's what it looks like from a high level on the results page. You can see within each test case that we've encoded some information here. So we have info about the wireless mode. In this case, it's Wi-Fi 6 or 802.11ax. Then it's the band. So in this case, it's the 5 gigahertz band. Then it is the transport, IPv6. And then it is the type of traffic and the direction. So TCP download, and lastly, the attenuation. So there's a lot of information encoded in these test case names. It is a bit long, but that's intentional. It's so that all of the information is there and you can just quickly look at the test case name to see exactly what test scenario was being performed. There's also a description for each test case, and this will tell you what the pass-fail metric is. So pretty straightforward. If you look at one of these logs, it's basically the same as the screenshot that I showed you before. You can see that CDRouter will connect, and then periodically we will print out the wireless statistics so that you can see exactly what's going on. You can watch these statistics as they scroll by and see how the signal and the noise change and how the MCS values change as the attenuation increases. And then what is probably my favorite feature with the new RvR test cases is the graphing that we added. So there's a new option here called Visualize Wi-Fi RvR. So if you press that button, you get these really slick graphs. And the gray dotted line represents the pass-fail metrics defined in TR398, and then the other data points are obviously the pass-fail, the final pass-fail performance metrics from the test cases that were run. So very nice, very useful. We also have a nice table down here, which is another new feature that allows you to quickly take a look at it and see. So you can see how the rate dropped as the attenuation increased. There's also filtering options over here as well. Just like any other CDRouter result, you have different ways that you can filter and slice and dice things. We've added some of that now to the graphing as well. So that's basically it. Let me go back here to the presentation.